Welcome to the project demonstration of electrical vehicle battery management system along with fire protection and fast and slow charging. So in this project the main features are like, so first of all fire protection with the help of this DS18B20 temperature sensor, which is a fire and waterproof temperature sensor to monitor the temperature of this battery pack. So we are using 3 batteries which are connected in series. In real time, based on the vehicle battery pack, the number of batteries will be increased, and the output voltage of our battery pack is 12 volt. So in order to measure the battery voltage, so we are using a voltage sensor here. This one is a voltage sensor, and a current sensor. When we on the load, the current will be monitored continuously from this current sensor. And whenever the battery voltage is low, using this selection switches to charge of a battery pack slow or fast, using these 2 buttons. One is the slow, then the what relay will get switched on, and the second one is the faster, the 2 relays will get switched on, so that the battery pack will get the maximum current from this charging circuit. So the main power flow of the project is, so we are putting 230 volts AC inputs to this transformer. So this transformer will step down the 230 volts to 9 volts of AC, and the voltage will be converted into DC with the help of this regulated power supply board, so which has the stages rectifier, filter, regulation. After filtration, we'll get the 12 volts of DC, and that is a charging voltage to this battery pack through these relays. And the operating voltage of our microcontroller and components is 5 volt. So to make that 12 volts DC to 5 volts DC, we are making use of this 7805 voltage regulator. This will regulate the 12 volts DC to 5 volts DC. So once we provide that to this motherboard, so which has a PIC 16F73 microcontroller, so it start reading input from the input sensors. As we discussed, the input sensor is like voltage sensor, current sensor, and temperature sensor. Based on these inputs, it will provide us the output voltage and current and the temperature on the 16:2 LCD screen, as well as based on these 2 switches inputs, the system will control these 2 relay boards directly. And whenever the temperature increases the threshold value, then automatically this cooling fan will get switched on, and also the buzzer will get switched on whenever the battery voltage is low or temperature is high. Based on these 2 conditions, the system will provide us the audible alerts through the buzzer. So let us check with the components connections. LCD interface at B2 to B7, C6, C7 for these 2 relays, A0, A1 for the voltage sensor and current sensor, C4 for the buzzer, C3 for this cooling fan, and C0, C1 for these 2 switches interfacing was done. So let us see the demonstration. Once you on the power supply to this cage, so the welcome to the project will be displayed on the LCD screen. We can see that, and then the battery pack voltage is displaying, and the current as 0 milliamps, and the temperature is 28.9. So let us make the battery voltage is 0 just by isolating the power supply from the battery pack to the motherboard through the voltage sensor. So low battery voltage. Now, so if you want to make the charging, just on this relay 1, let it switch it on. Now it is charging through this relay pack, and 2 relays got switched on. So after battery getting fully charged, then automatically these relays will get disconnected automatically. This is the automation operation while charging the battery pack from the overcharging protection. Coming to the current also. So when we connect the load to the system, so we can see the 1020 milliamps of current was consumed by this load here. So after we disconnect that, you can see that 0 volts, 0 milliamps of current. Now let us increase the temperature. So manually we are increasing the temperature in order to provide the alert system. As we can see, the voltage is increasing. So when it reaches the threshold value, then automatically the buzzer will be provide the audible alerts. So when it crosses the 50 degrees centigrade, then we'll get the audible alerts, right? And we can see the fan got switched on. So let us place this inside water to make it is normal temperature. Then when it is reaches the normal temperature, automatically this fan will get switched off, right? Right. In this manner, we are going to providing the safety and security system for the battery management in electrical vehicles. Thank you.